So we're going to continue talking about functions, and we're going to look at specific type of functions called a one-to-one function. And the idea with this is that we're going to talk about how every x value is only going to go to one y value. And in the case of some y values, you may see some graphs, like we'll look at an example, where the y value could be the same y value, but each x can only go to one y that's its own unique y value. So let's take a look at a couple examples so I can explain what I mean. And they have us doing a simple mapping for f of x and g of x. So again, I'm just going to put in for f of x, they want me to put in -2 into 2x. So I'm just going to show you substitution. In this case, it'd be -4, 0. If I do 2 times 0, I'm going to get 0. And then 2 times 2 give me +4. Now with g, something unique happens because it's a exponent. Well, if I do -2 squared, I get 4. If I do 0 squared, I get 0. And if I do 2 squared, I get 4 again. So here and here, I have the same output or range value for two different domain values. So in part B, what's different between these two? In g of x, each input has an output value that is used more than once. Kind of run out of space there, but used more than once. So they're both, in fact, functions, but now f of x is actually what's called a one-to-one function, because every one y value and one x value match up with each other, and we don't have that repeat of a y value like we did have in some functions we talked about, like quadratic functions. So let's look at some examples. Now they got 4 tables, and they want us to figure out which one is a one-to-one function. Well, first off, let's look for ones that are not functions at all. So for it to be a function, each x can only go to one y. So in the case of 1, we have 4 going to 2 different numbers. So this is not a function. And the same thing with 4. This one is not a function, because you have -2 going to 2 separate answers. So that leaves us with 2 and 3. And in the case of 2, this is a function, but we do have a case right here. Each number goes to one answer, but we do have the case right here where we have the output value repeated. And 3 would be our one-to-one, because each x only goes to each y value one time. So 3 is going to be our answer for this. 2 is a function, but again, it's not one-to-one. Now, just like in that you could find out in a table, I know some people have talked about before what's called the vertical line test. So for A, it says circle the 2 graphs that are functions. Well, any graph that passes the vertical line test is a function. So 1 and 4 are functions. Okay, 2 and 3 are not. And the one that's going to be a function in this case is going to be 4, because to be one-to-one, it has to pass the horizontal line test. Okay, as well. So if I was to draw a horizontal line, it only crosses it once, but if I draw a horizontal line on 1, I have 2 points, which means I have 2 cases of the same y value taking place. And you can see in the box below it kind of talks about what that horizontal line text is, so you can look at that as well. So, kind of talking about what we just talked about, okay? What I'd like you to do is take a look at exercise 4. You can pause the video right now and try that one on your own. And then, with exercise 5, they give us the absolute value function. So to get to that absolute value sign, it's also on the board in class. You'd press the math button, arrow, and then you want to pick ABS. And they want us to show by example that this is not a one-to-one function. So you can prove it by looking at the graph or the table, but I'd like you to try these two exercises right now, and then if you're in class right now, let me check it, and if not, make sure I check it when you do come to class. All right, and good luck.